Welcome back to Sleepy Science History. Tonight, I want to invite you to stretch out somewhere comfortable, loosen your shoulders, and let your mind wander with me for a while. I have a question, one that sounds almost like the beginning of a dream. What if the speed of light were 10 times faster than it is now? Pause with me here. The speed of light, something we usually imagine as the ultimate boundary, the cosmic speed limit, is already astonishing. In our world, it's about 300,000 kilometers per second. That's so fast it circles Earth 7.5 times in just one heartbeat. Now, imagine multiplying that by 10. Imagine light racing along at 3 million kilometers per second. How would the universe look? How would we live? Would our world be brighter, stranger, or perhaps gentler than the one we know? I like to think of questions like these as lanterns. You pick one up, hold it against the dark, and the glow reveals hidden paths you never noticed. This one, in particular, has many winding trails. So let's stroll down them slowly, with curiosity guiding our steps. Have you ever stood outside on a clear night, gazing at the stars? They twinkle ancient and far away, and we remind ourselves, those lights are old. The star whose glow touches your eyes tonight may have sent that message years, decades, or even millennia ago. With light as it is, we are always peeking into the past. But if light were 10 times faster, how would that change? Would the stars suddenly seem closer? Would the past collapse into the present, giving us a fresher view of the cosmos? Let's imagine. If the light of the sun currently takes about 8 minutes to reach us, then in this faster light universe it would take less than a single minute. Can you picture that? Sunlight practically instant, as though the universe were far more responsive, like a friend who answers your text before you even finish typing it. What would that feel like to live in such a nimble cosmos? Would the universe seem smaller, less remote, almost like a neighbor leaning over the fence to say hello? I wonder, too, about our sense of time. Physics tells us that the speed of light isn't just a detail about photons. It's a stitch in the very fabric of reality. The laws of cause and effect, the way clocks tick, even the possibility of time travel, all of these are woven around that constant. So if we tugged the thread, if we made light faster, would the tapestry unravel? Or would it reweave itself into a pattern we can barely imagine? Perhaps in this universe, the galaxies wouldn't feel so unreachable. Right now, when astronomers look through telescopes, they see light that has traveled billions of years. They're looking back to when galaxies were young, when the universe itself was barely stretching its arms. But if light were 10 times faster, maybe the messages wouldn't be so delayed. Maybe we'd see the universe closer to how it is now. Would that make us feel more connected to the cosmos, less like outsiders looking back through dusty photo albums, and more like participants in a living, breathing story? You might ask, would the stars themselves change? Would they burn differently under faster light? Strangely, no, the stars would still fuse hydrogen into helium, still flare and fade in their own patient rhythms. But our perception of them would shift. The sky might feel more immediate, more alive. Imagine walking outside and looking up, not at the long-ago glow of history, but at something closer to the universe's present moment. Wouldn't that alter the poetry of stargazing? Now, let's bring it closer to home. What about our daily lives? If light were 10 times faster, electricity would ripple through wires in a blink, nearly instant. Fiber optic cables carrying the internet across oceans would deliver data with barely a pause. Could you picture a world where the word lag didn't exist, where messages and signals moved so quickly they felt like thoughts themselves? Would our conversations stretch across the globe as seamlessly as if we were whispering into one another's ears? Yet, I wonder, would we actually feel more connected? Or would we simply find new ways to be impatient? You know how when cars got faster, people didn't suddenly become serene. Instead, they demanded highways and quicker commutes? If light itself granted us this new gift, might we, too, start hungering for even greater speed? It's a question worth lingering on. And then consider travel, the eternal dream. Spaceships bound for distant planets, explorers yearning for other worlds. Right now, the vastness of space keeps most of that dream out of reach. Even with our best rockets, it takes months to reach Mars. But if the very fabric of physics allowed for faster communication of energy and information, would that bend the rules for ships as well? Could astronauts cross the gulf more swiftly, guided by a universe that moves with lighter feet? I find myself smiling here because it's easy to get carried away, to imagine a galaxy where vacations on Saturn are as casual as weekend getaways. But reality tends to whisper a reminder. Faster light doesn't automatically mean faster ships. Rockets are bound by mass and momentum. Still, perhaps, technology might evolve differently in a universe where information is never so delayed, where science itself feels less like a waiting game. You might be wondering, what about Einstein? His theory of relativity is built on the constancy of light speed. Wouldn't changing that pull the rug out from under the entire structure of modern physics? And yes, it would. Relativity ties together time, space, and light like an intricate dance. A faster light would rearrange the steps, change the rhythm. Time dilation, the slowing of clocks as you near light speed, would stretch out in new ways. The universe might permit stranger journeys, maybe even allow us glimpses of possibilities that feel forbidden now. Does that excite you? Or does it make you uneasy? The thought that our most trusted theories could dissolve into something new? Personally, I feel both, a thrill and a shiver. After all, isn't that what science is at its heart? A willingness to admit we don't know, to peer into the fog with nothing but curiosity as our compass. Let me paint you a picture. Imagine standing by the sea, watching waves crash against the shore. The waves are light, the beach is reality. If the waves rolled in 10 times faster, would the coastline reshape itself? Would it erode differently, form new shapes, new rhythms? This is how I like to think about the speed of light. Not just as a number, but as the heartbeat of the universe itself. And if that heartbeat quickened, what kind of melody would play? Would we learn to dance to it or stumble at first, clumsy and surprised? Would human history have unfolded the same way, our inventions, our philosophies, our very sense of patience and longing? Or would we have grown into a different species, one attuned to a swifter song? As I speak these words, I know they're just speculation. But speculation is not a waste of time. It's a playground for the mind, a way of honoring the mysteries we cannot solve. Perhaps you feel the same, that quiet joy in asking what if, even when answers drift just beyond reach. So here we are, at the edge of possibility, staring at a universe 10 times quicker, 10 times more immediate. And I find myself returning to the simplest of questions. Would we feel closer to the stars, or would they still seem distant, no matter how fast their light arrives? I leave that thought with you, like a pebble dropped into still water, its ripples expanding softly through the quiet of your own imagination. What does it mean for time itself if the speed of light were 10 times faster? Would hours and minutes stretch differently? Or would our clocks still tick in the same gentle rhythm we've always known? Time, after all, isn't something we can hold in our hands. It's not like a stone you can weigh or a thread you can cut. It's more like the river you float along, sometimes calm, sometimes quick, always pulling you forward. But what if the current itself flowed differently, reshaped by the very speed that governs the universe? Einstein showed us that time and space are braided together, inseparable strands woven into a single fabric. The speed of light is the loom that threads them, the constant that decides how events unfold and how distances are measured. If that constant were shifted, if the loom were set to weave 10 times faster, would our lives be stitched into a new kind of pattern? Would journeys feel shorter, and would the space between seconds feel lighter, thinner, almost as if time itself breathed more quickly? Imagine holding a flashlight in your hand and pointing it into the night. Normally, that beam races outward at 300,000 kilometers per second, a speed so great that it feels instant to you. Now picture it shooting out 10 times faster, beyond comprehension, beyond imagination. Would that beam change the way shadows dance on the walls? Would your sense of distance collapse, as if the universe were whispering, "I am nearer than you think"? If time and light are bound so closely, then perhaps our own lives would carry a different rhythm. When you watch a train speed past, you know that someone on that train experiences time just a little differently than you do. The faster they go, the slower their clock ticks compared to yours. This is relativity in action. But if the cosmic speed limit were 10 times higher, then those differences would only show up at even greater speeds. Wouldn't that mean our daily lives would feel more synchronized, more unified, less fractured by motion? Would time feel steadier, less fragile in our hands? Yet there's another side. If the universe allowed light to rush 10 times faster, then the very boundaries of possibility would stretch. Would spacecraft, inching closer to this higher ceiling, experience stranger distortions of time? Could we, in theory, live longer on interstellar journeys, skipping ahead into futures we can only dream of now? And if so, would humanity choose to chase that possibility, or would we remain rooted here, content with our gentle earthbound days? Think of the stars again. Right now, when you gaze upward, you're a time traveler of sorts, looking back into ancient history. Some stars you see tonight may no longer even exist, their final breath already spent. You're catching echoes of their life. But if light were 10 times faster, the echoes would be fresher. The cosmos would reveal itself with less delay, less distance between cause and effect. Would the night sky feel less like a museum of ancient relics and more like a live performance, unfolding in real time? There is a curious intimacy in that thought. To watch the universe as it is, not as it was, might make us feel less alone. Instead of living with ghosts of stars, we would live with their presence. And yet, isn't there something hauntingly beautiful about the way things are now? That every point of light is a letter from the past, a story that took so long to arrive? If the speed of light were swifter, would we lose that poetry, that sense of patience, of receiving a message carried across impossible distances? Let's bring the question closer into the realm of human experience. Communication is already astonishing. You send a message across the globe, and in a fraction of a second, it arrives. But in this new reality, it would be even faster, so quick it might as well be thought itself. Would this erase the feeling of distance between people? If someone you love is across an ocean, would their words feel less far away, less burdened by geography? Or would we simply take it for granted, forgetting again how miraculous it is that voices and images can leap across the earth at all? I find myself wondering, too, about memory. We often speak of memories as light trapped in time, reflections bouncing through the corridors of our minds. If the laws of light shifted, would memory itself feel different? Would the past seem closer, more immediate, because the universe insists on swifter exchanges between events and their echoes? Or would our inner lives remain the same, tied not to physics but to the fragile workings of neurons and dreams? Then there is causality, the idea that one thing leads to another, that the arrow of time points only forward. Light enforces that arrow. It tells us how signals move, how information travels, how events ripple outward. But with a faster speed, would those ripples spread differently, perhaps softening the boundaries between here and there, now and then? Would reality itself become more fluid, like watercolor bleeding across paper? It's tempting to imagine practical miracles. Astronomers might chart galaxies with unprecedented clarity, peering deeper into space without waiting for ancient light to reach them. Engineers might design machines that use faster electromagnetic signals, creating technologies we can scarcely envision. Even the simple act of seeing photons striking your retina would occur with such immediacy that vision might feel sharper, more responsive. Would our very perception of the world feel heightened, as if reality were keeping pace with our every glance? But there is also a quiet humility in asking, what would remain unchanged? The trees outside would still grow in their patient seasons. Rivers would still wind toward the sea. Your own heart would still beat in its steady rhythm. Perhaps the greatest wonder of all is that the speed of light, however fast or slow, doesn't alter the gentle rituals of daily life. It frames them, yes, like the edges of a painting, but the colors within, the laughter, the sighs, the drifting of clouds, might remain much the same. So then, is the speed of light a tyrant, dictating the structure of our existence? Or is it a stagehand, unseen, setting the tempo while we dance our human stories? If the tempo quickened, would we dance differently, or would we still step to the music of love, curiosity, and longing? There is a strange comfort in these questions, even if answers evade us. To imagine a universe where light is swifter is to glimpse how delicate the balance of things truly is. Every law of nature is like a note in a symphony, and if one note changes, the melody shifts. And yet, perhaps the melody is always beautiful, no matter the tempo. As you drift through this thought experiment, I wonder, how would you feel if the night sky above you were no longer a window into the past, but a mirror of the present? Would you long for the poetry of delay, the romance of ancient starlight? Or would you embrace the immediacy, the closeness, the sense that the cosmos is alive and awake with you at this very moment? The question lingers, like a candle flame trembling in the quiet air. And perhaps that is enough, not to solve, not to conclude, but to let the wonder settle softly, like starlight itself. If light were 10 times faster, how would it reshape the story of the universe's birth? Would the Big Bang itself have unfolded differently? Or would the newborn cosmos still have blossomed from that single point of unfathomable density and heat? When we talk about beginnings, we often imagine them as sudden, like a door flung open or a match struck in the dark. But the universe's beginning was not a single instant. It was a swelling, an expansion, a growing rhythm that has never truly stopped. So if the heartbeat of light had been quicker, would that rhythm sound different to us now? The universe, as scientists describe it, has a kind of horizon, a boundary of what we can see. Light has been traveling since the very first moments, carrying stories from the past, and those stories stretch about 13.8 billion years. Beyond that, the light hasn't yet arrived, so the edge of our vision fades into silence. But what if light had raced 10 times faster? That horizon would push outward, showing us more of the cosmic ocean. Would we, in that case, have grown up in a universe that feels less mysterious, less veiled? Or would it simply present us with bigger questions, because even with more revealed, there would still be endlessness beyond? Think of it like standing on a beach. The waves you see define your world, but you know the ocean goes on. If those waves came to you faster, if more of the sea revealed itself, would you feel larger and safer in your understanding, or smaller and more overwhelmed by the immensity? The faster the light, the more sky revealed, the deeper the map of galaxies we could trace. And yet, would knowledge truly make the unknown shrink, or only remind us of how boundless it always was? Cosmic history is written in light. When astronomers peer through telescopes, they don't just see dots of stars, they see time itself stretched across the void. The further they look, the further back they travel. But in a faster light universe, those time capsules would arrive less aged, less stretched. Would the expansion of the universe, that mysterious stretching of space itself, appear gentler to us? Would the redshifts we measure, the lengthening of light as galaxies race away, seem less dramatic? Might we conclude, perhaps wrongly, that the cosmos was calmer, less hurried in its expansion? Then there is the question of cosmic microwave background radiation, the faint glow left over from the early universe. Today, it surrounds us as a whisper from 380,000 years after the Big Bang, the moment when light could finally move freely through space. If light were 10 times faster, would that whisper reach us differently? Would the afterglow of creation be more subtle, more quickly smoothed out, less patchy in the sky? Could we still trace the fingerprints of the early cosmos, or would some of its secrets be blurred by the swiftness of their journey? The very birth of stars and galaxies might have shifted, too. Light governs energy, heat, and the balance between matter and radiation. In a universe where photons dart more quickly, would the first stars ignite sooner, gathering matter into brilliant furnaces of fusion? Or would they form later, because gravity would need more time to pull against the swifter, more restless sea of radiation? The timing could change everything, the rhythm of cosmic dawn, the ages of galaxies, even the chemistry of planets like ours. And so, another question arises: would Earth itself exist if light had been 10 times faster? The chain of cosmic events is delicate. Stars needed to live and die to scatter heavy elements, to seed planets with the ingredients of life. If those cycles were nudged even slightly, might the story of Earth and its oceans and its people have never unfolded? Or perhaps life would have blossomed elsewhere, under different stars, written in a different alphabet of possibility. It is humbling to think that the laws of physics, numbers that seem so abstract, might hold the fate of existence itself. Change a single constant and the balance tilts, the story bends. Yet the imagination delights in these bends, doesn't it? To wonder about other versions of reality, other paths not taken. Could there be universes, hidden and unreachable, where light races differently, where beings unlike us look up at unfamiliar skies and ask their own questions? There is another layer to consider: time's arrow. The faster light, the faster entropy, the tendency for order to dissolve into disorder, might unfold. Would that mean universes burn through their possibilities more quickly, stars aging faster, galaxies scattering sooner? Or would it be the opposite, the swiftness of light stabilizing the spread of energy, stretching out the lifespans of stars? How fragile is the line between a cosmos that endures for billions of years and one that flickers briefly, like a match in wind? I like to think of the universe as a storybook, each page written in photons. Our telescopes are readers tracing the ink. If the ink dried more quickly, if the words reached us fresher, would the story seem shorter? Or would it feel more alive, as if the cosmos were speaking directly to us instead of sending letters long delayed? Would you, standing under the night sky, feel like a character within the tale rather than a reader of old chapters? And what of the mysteries that still confound us? Dark matter, dark energy, the unseen scaffolding that holds the cosmos together. Much of our evidence for these comes from how light bends, stretches, and moves. If light had always been 10 times faster, might our interpretations be different? Perhaps what we call dark matter would appear less necessary, or dark energy less urgent. Could entire fields of science be rewritten, their puzzles vanishing in the altered behavior of photons? And if so, would that make the universe less mysterious, or only mysterious in new ways we cannot predict? There is a gentleness in realizing how dependent we are on the constancy of light. It is both our messenger and our measure. Without it, we would be blind to the past, unmoored in the present. A faster light would give us swifter messengers, but would that gift come at the cost of patience, of distance, of the slow unfolding of mystery? Picture yourself watching a sunset. The light you see has traveled only 8 minutes from the sun. In a faster light cosmos, it would have arrived in less than one. The sky would still blush with the same colors, the same golden wash. But would you feel the difference, deep down, knowing that the universe's great clock ticked at another pace? Would that knowledge change the poetry of twilight, or would the beauty remain untouched, indifferent to the numbers? Sometimes, I think the most important part of these questions isn't the answers but the act of asking. To wonder about a faster light is to lean close to the cosmos and whisper, "What else might you be?" It is to admit that even the firmest constants could have been otherwise, that existence itself is perched on delicate choices. And so I leave you with this. If the cosmos had been revealed to us more swiftly, if light had painted the universe 10 times faster, would we be more certain of our place, or less? Would we feel like masters of knowledge, or wanderers in an even vaster maze? The silence between those questions is its own kind of answer, a reminder that the universe's greatest gift may not be certainty at all, but wonder. What would it mean for gravity if the speed of light were 10 times faster? Would the pull that binds us to the Earth, that keeps the moon circling overhead and the planets tracing their paths, behave in a gentler or swifter way? We tend to think of gravity as an invisible tether, a quiet and patient force, but physics reminds us that gravity also communicates at the speed of light. If the sun suddenly vanished, its light would take 8 minutes to leave us, and so would the change in its gravity. But if light traveled 10 times faster, the whisper of gravity would reach us almost instantly. Would the universe, then, feel tighter, more immediate, with every motion and every tug stitched together more quickly? It's an odd question because gravity is already so subtle. You feel it now in your body, in the weight of your limbs, yet you don't hear it or see it. But if its influence raced through space faster, would the cosmos seem more harmonious, less delayed, like an orchestra where every instrument stays perfectly in time? Perhaps galaxies would hold their spirals with greater precision, their stars bound more tightly to their centers. Would the Milky Way's arms curl more neatly, as though sculpted by an unseen hand with quicker strokes? Think of how Earth orbits the sun. The delicate balance is like a dance. The planet pulled inward by gravity while its momentum carries it around and around. That balance depends on the timing of forces, on the way gravity propagates. If the speed of light set that pace faster, would Earth's path shift? Would our orbit tighten, or would it remain steady, simply woven by quicker threads? And if it shifted, even slightly, would the seasons that shape our lives, the turning of spring into summer, the long quiet of winter, unfold differently? Then there is the moon, our companion in the sky. Its orbit is already drifting slowly outward as tides transfer energy between Earth and its satellite. But in a faster light cosmos, would that drift change? Would the moon's gentle retreat be slowed or hastened, altering the rhythms of tides, the cycles that life in the oceans depend upon? If you stood on a beach watching waves crash, would their timing carry a different music, one composed under a quicker law of gravity? The very structure of the cosmos rests on the dialogue between gravity and light. Stars are born from the collapse of gas under gravity's pull, igniting fusion at their cores. Galaxies form from clouds drawn together across vast distances. If the signals of gravity traveled faster, those collapses and gatherings might unfold differently. Would stars be denser, igniting earlier in their lives? Would galaxies cluster more tightly, as though the universe itself were more impatient in its creation? Or would faster communication smooth out the rough edges, preventing clumps and collisions that give rise to diversity in the cosmos? Imagine black holes, those mysterious wells where gravity grows so strong that even light cannot escape. If light were faster, would their horizons, the boundaries beyond which nothing can return, shrink? Would black holes be less formidable, their hunger curbed by the quicker pace of photons? Or would they remain just as terrifying, still capable of bending reality, but now with their secrets hidden behind even swifter veils? And what of gravitational waves, those ripples in spacetime born from colliding stars and black holes? We have only just begun to detect them, their faint tremors reaching Earth after journeys lasting billions of years. If gravity moved faster, would those ripples rush to us with less delay, painting a fresher portrait of the events that caused them? Would our instruments sing with more immediacy, as though the universe were telling its stories in real time rather than after eons of silence? I wonder, too, about the fragile balance that allows planets like ours to cradle life. Gravity shapes the orbits of comets and asteroids, some of which have struck Earth with devastating force. If their paths were guided by a swifter gravitational hand, would history have unfolded differently? Would some collisions have missed, sparing species from extinction? Or would new impacts have been drawn, rewriting the story of life? Could humanity itself exist in such a timeline? Or would the thread of evolution weave into something entirely other? The Earth itself would still hold you, of course, pulling you gently toward its center. Your feet would not float away. The trees would not lose their roots. But perhaps the way mountains rise and rivers carve valleys would shift over millions of years, subtle changes echoing through geology. A planet sculpted by gravity that speaks more quickly might wear a slightly different face. Its peaks sharper, its oceans wider, its landscapes shaped by forces that never hesitate. And what about you, standing there beneath the stars? Would you feel gravity any differently? Perhaps not in your body, not in the heaviness of your bones. But your sense of distance, your sense of how the universe moves might change. You might look at the planets and stars and feel them closer, more responsive, less like distant wanderers and more like dancers moving in time with you. Would that make the cosmos feel friendlier, less aloof, or would it unsettle you, the thought that the universe reacts so swiftly to every shift? There is another question. Would relativity itself, the intimate bond between light, space, and time, remain the same? If gravity is the curvature of spacetime, and light sets the pace of that curvature, then altering one changes the whole dance. Perhaps time near massive objects would warp less dramatically. Perhaps the strange slowing of clocks near black holes would be gentler, less pronounced. Would that make the universe more predictable, or would it strip away some of its strangeness, some of the awe that comes from knowing time itself can bend? In this imagined cosmos, where light is faster and gravity quicker, would the universe endure longer or burn through its story in haste? A swifter exchange of forces might mean stars collapse sooner, galaxies scatter earlier, and cosmic structures unravel faster. Or it might mean greater harmony, a universe more tightly knit, more resilient. The truth is unknowable, but the wondering itself feels like standing at a crossroads where every path is infinite. Think of a pendulum swinging. Its rhythm depends on gravity, on the steady pull downward. If that pull communicated more quickly, would the pendulum tick differently? Perhaps only slightly, perhaps imperceptibly to human senses. Yet across cosmic scales, those tiny changes would ripple outward, reshaping the grand cycles of stars, galaxies, and time itself. Could you imagine listening to a cosmic clock that ticks at a new tempo, its hands tracing patterns both familiar and strange? And still, for all the speculation, there is one constant: the feeling of wonder. Whether gravity is quick or patient, whether light runs or strolls, the universe offers itself to us as a mystery. It doesn't matter if the horizon of knowledge shifts outward or inward. What matters is that we are here to look, to ask, to marvel. So perhaps the deeper question isn't how the cosmos would behave if light were faster, but how we would respond. Would we rush to chart the new laws, to master them, to claim certainty? Or would we pause, as we do now, to watch the stars with quiet reverence, to feel the pull of gravity not just in our bodies but in our hearts, binding us to the universe in ways no equation can fully capture? The thought lingers. A universe where gravity speaks with swifter words, where light paints with quicker strokes, where the fabric of space-time hums at a higher tempo. Would it be a harsher song or a gentler one? And if you closed your eyes tonight and felt the weight of your body against the earth, would you even know the difference? Or would you simply smile at the mystery, content that no matter the speed, the universe still holds you close? What would it mean for life if the speed of light were 10 times faster? Would our senses perceive the world differently? Or would the rhythms of our daily existence remain much the same? We rely on light for sight, for warmth, for the cycles of day and night that cradle us. But if its pace were swifter, would the patterns of life itself unfold under a different script? Take vision, for instance. Every glance you cast depends on photons racing into your eyes, striking your retinas, sparking electrical signals that your brain transforms into images. Already, this happens so quickly that it feels immediate, as though the world is painted for you without delay. But what if that process were backed by light 10 times faster? Would the world feel sharper, more immediate, almost too responsive? Or would the change slip past unnoticed, because our minds are tuned not to the speed of photons but to the slower rhythm of thought? Consider plants, the green alchemists of Earth. They weave light into sugar, turning sunlight into life itself. Would faster light change the way leaves drink from the sun? Perhaps not in the chemistry, which depends on energy more than speed, but in the subtle timing of how energy reaches Earth. Sunlight would arrive in less than a minute, rather than 8. Would that alter the delicate dance of photosynthesis, or would plants sway under the same rhythms, unconcerned with the faster beat of photons? Animals, too, live by cycles shaped by light. Birds migrate guided by stars, flowers open to dawn, humans rest when darkness falls. These cues depend on the arrival of light, but would a faster light truly change the turning of Earth, the rising of the sun, the familiar cadence of day and night? Likely not. The planet would still spin, the seasons would still unfold. Yet perhaps the subtle relationship between life and the cosmos would shift, lessening the sense of delay, the gap between cause and effect. Would we feel more aligned with the universe, as though its signals reached us without hesitation? Then think of communication not just between machines but between living beings. Already, light enables us to speak across oceans, to see faces on screens from thousands of miles away. In a faster light world, those exchanges would be nearly instantaneous, as though geography had dissolved. Would families feel closer, friendships less strained by distance? Or would we grow restless, demanding even more speed, forgetting once again to marvel at the miracle of connection? There's another layer, subtler still. Life on Earth is not only guided by light but by the vast history of the cosmos. The heavy elements in our bodies were forged in stars, scattered by supernovae, carried across space by light and gravity alike. If light had always been swifter, would those stellar life cycles have unfolded differently? Would iron in your blood or calcium in your bones exist at all, or would the chemistry of life wear another face? Could evolution have taken a different path, creating beings unlike us under skies that reveal themselves in a different tempo? Pause and picture evolution as a story written not in words but in timing. Mutations, extinctions, opportunities, they arrive in rhythms shaped by the cosmos. If light and gravity whispered to one another more quickly, would those rhythms alter? Could Earth's history have been punctuated by different events? Asteroids missing instead of striking, climates shifting at new paces, ecosystems adapting along unfamiliar trails? Might life have flourished sooner or later, or in forms we cannot even imagine? And what of us, humans with our peculiar habit of wonder? Would we still lift our eyes to the sky, still ask questions about existence, if the stars felt less like ancient messengers and more like immediate companions? There is something humbling about starlight as it is, that every twinkle is a story from long ago. If that distance of time collapsed, would we lose some of the poetry that shapes our curiosity? Or would we gain a new intimacy, a feeling that the universe is speaking with us directly, not through echoes but through present conversation? Consider culture. Art, religion, philosophy all have been shaped by the mystery of the heavens. Myths arose from the slow dance of stars and planets, from the recognition that light travels across unimaginable gulfs. If light had been swifter, would those myths carry different meanings? Perhaps the ancients would have felt less awe at the age of starlight, more closeness to the gods above. Perhaps religions would frame the cosmos not as distant and eternal but as immediate and participatory, with divine presence felt in real time. Would our stories about creation, destiny, and belonging look different under such skies? Then there is the human sense of patience. Waiting is woven into our lives. We wait for dawn, for harvest, for seasons, for years to pass. Even science has required waiting, astronomers watching light trickle in from far galaxies, historians tracing signals across centuries. If the speed of light were swifter, some of that waiting would vanish. Would that change who we are? Would we become less patient, less contemplative, accustomed to a universe that answers instantly? Or would we still find new ways to practice waiting, to honor the slow unfolding of time that light alone cannot erase? Think of medicine, too. Today we peer into the body with light, X-rays, MRIs, lasers. These tools depend on photons obeying their constant rules. If that constant were faster, could medicine advance more quickly? Could diagnosis be instant, treatments swifter, healing more efficient? And yet, even if photons raced faster, the body itself would still take its time. Bones would still knit slowly, wounds would still close in days. The faster rhythm of light might give us new instruments, but life itself would remain bound by its own tempo. There is a gentleness in realizing that light, though fundamental, is not the whole of existence. Life is built not only on speed but on slowness, on processes that take their time. Trees grow ring by ring, oceans shift by tide, generations rise and fall. Even if light hurried along at 10 times its current pace, the essence of life might remain tethered to the slow dance of biology. Wouldn't that be comforting, to know that some things endure unchanged, no matter how the universe hums around them? Yet I can't help but wonder, would our dreams be different? Humanity dreams of travel, of reaching the stars. With faster light, perhaps communication with distant explorers would feel less daunting, less lonely. Colonies on Mars might speak to Earth almost in real time. A probe near Pluto could send images back almost instantly. Would that make the cosmos feel more accessible, more welcoming? Or would the vast distances remain vast, a reminder that even light, however swift, is not infinite? Imagine standing beneath the night sky in this alternate universe. You see stars, but their light is fresher, their presence nearer. Do you feel closer to them as though you could almost touch? Or do you still feel the enormity, the infinite stretch that no change in speed can erase? Perhaps both. An intimacy paired with awe, a nearness paired with distance. Perhaps that duality is what defines us. Always reaching outward, always aware of how far we have to go. So, if the speed of light were 10 times faster, what would life be? Perhaps not wholly different in its day-to-day rhythms. We would still rise with the sun, still eat, still love, still age. But beneath those familiar patterns, the threads would weave differently. The timing of history, the shape of culture, the texture of myth, even the chemistry of our bodies might shift. The universe would write its story with a quicker pen, and we would be characters in that altered script. And you, hearing this question, what do you imagine? Do you picture a brighter world, more connected, more immediate? Or do you feel a tug of sadness, thinking of what might be lost? The ancientness of starlight, the poetry of distance, the patience of waiting? Perhaps the answer lies not in choosing but in holding both possibilities, letting them sit side by side like two voices in a quiet duet. The thought lingers. A cosmos with quicker light, a life shaped by swifter messengers. Would we thrive differently, or simply find new ways to marvel at the mystery? And as you breathe, as you sit in this moment, perhaps the most comforting truth is this: whether light is fast or faster, the universe still surrounds us with wonder, still asks us to look, to feel, to question, to dream. What would it mean for technology if the speed of light were 10 times faster? Would our machines, our networks, our inventions be reshaped into something unrecognizable? Or would the changes whisper at the edges, subtle yet profound? Technology, after all, is the art of harnessing natural laws. Every wire, every circuit, every signal we rely on is bound by the pace at which light moves. So if that pace were swifter, would civilization itself accelerate? Or would we simply find new limits to test? Think first of communication, the lifeblood of our modern world. Messages today race across continents in under a second, carried through cables of glass where photons dash along, bouncing inside like restless spirits. If their journey were 10 times faster, the lag we already barely notice would nearly vanish. Would video calls feel like conversations across the table, with no delay at all? Would data stream so fluidly that the very concept of buffering became a forgotten relic, a word as outdated as quill or telegram? And if so, would we feel more connected, or would we simply take that closeness for granted, as we so often do with miracles made ordinary? Then think of computation itself. At its heart, a computer is a dance of electrons and photons, moving through circuits, switching on and off in unfathomable numbers each second. The faster signals can travel, the smaller and swifter these machines might become. Could we imagine processors not just billions but trillions of times more capable, weaving simulations of galaxies, decoding mysteries of biology, rendering entire worlds in the blink of an eye? Would the boundary between thought and calculation blur, as if our machines were thinking almost alongside us, not behind? And what of the internet, that vast nervous system of humanity? Today it spans oceans and skies, a web of connections linking billions of minds. In a faster light universe, its threads would tighten, its pulses moving with unmatched immediacy. Would knowledge feel less like something distant and more like something always at hand, a seamless extension of memory itself? Or would the sheer speed overwhelm us, forcing us to ask whether the challenge was ever distance at all, or simply our capacity to absorb what is already within reach? Imagine spacecraft and probes exploring the solar system. Right now, signals from Earth take minutes to reach Mars, hours to reach the outer planets. Commands crawl outward, and data trickles back, like a conversation stretched across time. But if light raced tenfold, that lag would shrink, and the dialogue between explorers and home would be almost casual. Would rovers wander Mars with greater freedom, guided in real time? Would probes near Neptune send back images so quickly they felt like postcards, not relics of the past? Might exploration itself feel less lonely, less remote, as though the cosmos were no longer so slow to answer? Energy is another realm shaped by light. Solar panels capture photons, turning them into currents that power our lives. Faster light wouldn't make the sun brighter, but the very physics of electromagnetic waves might alter, reshaping how we transmit and use energy? Could we beam power across continents with perfect efficiency, sending light as easily as water through pipes? Might lasers sculpt industries, medicine, and art in ways we can scarcely imagine? The universe, in this alternate script, might grant us a tool so finely tuned, so immediate, that the boundary between energy and thought blurred into something almost magical. And yet, technology always carries paradox. Faster light might not solve every challenge. It might create new ones. Circuits could overheat more easily as signals grew denser. Systems might need to adapt to forces unfolding with less delay, demanding greater precision. Would our inventions keep pace, or would we stumble, caught between old habits and new laws? Technology is not just about what is possible but about what humans can grasp, can shape, can control. A faster universe might outpace our readiness, reminding us that progress is always a negotiation with limits. Consider entertainment, too, the ways we tell stories. Today we stream films, play games, share music across vast distances. In a faster light world, those stories could be woven in real time across continents, collective experiences shared without interruption. Could entire concerts be performed simultaneously across oceans, with no delay between musicians? Could global classrooms bloom, teachers and students speaking as if seated side by side, though separated by half a planet? Would culture itself feel less fractured, more unified, or would speed only amplify the noise, the endless flood of voices and images competing for attention? There's also the question of artificial intelligence. Already, machines learn, adapt, and respond through vast flows of data. With signals traveling 10 times faster, their reach and responsiveness could grow beyond recognition. Could we one day converse with an intelligence spanning the globe, its thoughts carried instantly across networks? Would it feel less like a machine and more like a presence, a companion woven into our daily lives? And if so, how would we define ourselves against that mirror, that partner shaped not by biology but by speed? But let us not forget the quieter side of technology, the tools that heal rather than dazzle. Medical imaging, surgeries guided by lasers, therapies shaped by light, all of these depend on photons obeying their constant rules. A swifter light might refine them, giving doctors clearer views, sharper instruments, faster diagnostics. Could diseases be caught in moments rather than months? Could recovery feel less like waiting and more like immediate renewal? Yet even then, healing would still take time. Cells would still divide at their own pace. Bones would still mend slowly. Technology might race ahead, but life itself would remind us that some processes cannot be rushed. I wonder about transport as well. Today, planes, trains, and ships move at their own speeds, limited not by light but by fuel, friction, and distance. Yet navigation, control, and safety depend on signals, GPS satellites, radar, communication systems. In a universe of faster light, those signals would guide more smoothly, more precisely, shrinking the margin of error. Would that give us skies and seas safer than ever? Or would we simply push our machines to go faster still, chasing new horizons of speed? And then the ultimate dream, space travel. Faster light does not mean faster rockets, but it changes the frame of possibility. If communication is immediate, if navigation is flawless, could we imagine venturing further, building colonies on moons and planets, daring to wander outward? Would the barrier between Earth and stars feel thinner, the gulf less intimidating? Perhaps humanity would be bolder, less afraid of silence, because silence itself would be shortened. Yet through all this imagining, one question remains: would faster light change our relationship with technology, or simply accelerate what we already are? We seek connection, and we build machines to bridge the gaps. We seek knowledge, and we build tools to gather it. We seek comfort, and we invent devices to ease our lives. If light ran 10 times faster, would these desires change, or would we still be the same restless species, always reaching, always inventing, always yearning? Picture a child holding a tablet, learning about the stars. In our world, their questions travel through layers of networks, answered in seconds. In a faster light world, those answers would come even quicker, the delay vanishing. Would that child feel more empowered, more inspired, more woven into the fabric of knowledge? Or would they simply grow used to it, expecting every question to be met with instant reply, losing the patience that wonder sometimes requires? Technology, in the end, is a mirror. It shows us not only what is possible, but who we are when faced with possibility. A universe of faster light would give us sharper mirrors, quicker reflections. Would we like what we see, or would we realize that speed cannot mend what is human, that understanding, compassion, creativity still unfold at their own pace? And so I ask, if light were 10 times faster, would technology make us gods of immediacy, bending reality at will? Or would it simply remind us, in its swiftness, that true wisdom lies not in speed but in the way we use it? The thought lingers, shimmering like a signal racing across the void, waiting for us to decide whether to listen, whether to slow down, whether to wonder. What would art and imagination become if the speed of light were 10 times faster? Would creativity find new colors, new rhythms, new ways of reaching across space and time? Or would human expression remain tied to the same timeless impulses of beauty and longing? We often think of art as separate from science, yet both are bound by light. Every painting, every film, every photograph, every illuminated manuscript depends on photons carrying patterns to our eyes. If those photons rushed along more swiftly, would our creations glow differently? Or would they simply find new ways to whisper the same truths? Think of painting first. A canvas is nothing but pigments reflecting light, each hue born from the way photons bounce. With a faster light, the reflections would still happen, but the act of seeing them might feel more immediate, more alive. Would artists feel that difference? Would a brushstroke gleam with an intensity beyond our current imagination, as if the world itself were more responsive to every shade? Or would the art remain what it has always been? A conversation between hand, mind, and heart, with light only the invisible servant carrying its message. Now think of cinema, the art of light in motion. A projector casts frames, and our eyes blend them into fluid stories. If photons traveled tenfold faster, could film itself evolve into something closer to living visions, images that respond with uncanny immediacy? Might directors create not only stories but immersive realities, where audiences across the globe watch together in perfect synchronicity, every flicker of light reaching them without delay? Would cinema become less about distance and more about shared presence, as if light stitched us all into the same theater, no matter where we sat? Photography, too, would carry a new intimacy. To capture a moment is to freeze light, to trap time in an image. If that light arrived 10 times sooner, would photographs feel less like records of the past and more like windows into the present? Imagine a picture of a star not millions of years delayed but closer to its true form, a portrait of something alive rather than long gone. Would art of this kind change how we think about memory, about permanence, about the fragile line between now and then? Music may seem untouched by light, yet even sound is shaped by photons when we record it, when we share it, when concerts stream across the world. In a faster light universe, a performance in one place could be felt instantly everywhere, a single note resonating across continents without lag or loss. Could art become global in a way we have never known, musicians and listeners bound together in a simultaneous breath? Would rhythm itself feel more universal, no longer broken by distance, but flowing through the world as a single song? And then there is literature, stories told not with light but with words. Yet even here, light plays its role. A book is read by light striking pages or screens, each letter revealed by photons. In a swifter light cosmos, would reading feel different? Likely not in the intimacy of thought, but perhaps in the way words travel. An author might share a story across planets, and readers might see it instantly, without delay. Would that make storytelling less local, less tied to place, and more cosmic? An art shared across worlds as easily as across towns? Consider architecture, the art of space itself. Buildings are designed not only for shelter but for the play of light, windows, shadows, reflections. In a universe of faster light, would architects design differently, capturing the immediacy of photons, creating spaces that feel more alive with every sunrise and sunset? Would stained glass glow with a brilliance beyond what we know, colors shifting in real time with the heavens above? Could cathedrals, temples, and modern skylines become living artworks, reshaped by the speed of the cosmos itself? Yet art is not just about form, it is about perception, about the way we experience beauty. If light carried messages more quickly, would our perception shift? Could our brains adapt to a faster influx of photons, interpreting scenes with heightened clarity? Or would we still see only what we are built to see? Perhaps art would remain the same in essence, because its magic lies not in the physics of light but in the way we, as humans, interpret it through memory, feeling, and imagination. Still, I wonder about virtual art, digital worlds crafted by computers and light. Already, we build simulations where people walk through imagined landscapes, where stories unfold inside luminous headsets. In a faster light universe, those simulations could become seamless, indistinguishable from reality. Would imagination itself expand into new dimensions, no longer limited by the clumsiness of lag or the imperfections of display? Could artists become architects of entire realities, painting not just canvases but worlds you could step into? There is a paradox, though. Sometimes art thrives not in speed but in slowness. A painting invites you to pause. A poem asks you to linger. Music carries you gently through time. If light were swifter, would we lose some of that patience, rushing through experiences too quickly? Or would we, in turn, seek out new forms of art that remind us to slow down, to breathe, to feel? Perhaps art would become a refuge from speed, a way to honor the stillness that technology and physics cannot erase. Think of myths again, the old stories told by firelight, by starlight. If the stars were closer in time, less ancient, would those myths hold the same power? Would gods and heroes seem less eternal, more immediate, as if they shared the same present as us? Would art lose its sense of longing for what is distant, or would it find new symbols to capture the mystery of a universe still endless, even if swifter? And what about memory, which is itself a kind of art? We hold moments in our minds, shaping them with imagination, retelling them with embellishment. Photons carry the raw images, but memory transforms them into stories. If light gave us fresher images, closer to the present, would memory change? Would nostalgia fade, replaced by immediacy? Or would we still weave tales of longing and distance, because that is simply what it means to be human? Perhaps the real question is whether art depends on the speed of light at all. Art is born of desire, desire to express, to connect, to understand. Faster light might give us new tools, new canvases, new instruments. But would it change the beating heart of creativity? Would we still paint dreams, sing sorrows, write epics, dance stories, even if the cosmos hummed at a different tempo? I think so. Art, at its essence, is not about physics, it is about the human spirit reaching outward. Yet there is something tantalizing about imagining artists in this swifter universe. Painters capturing starlight as it truly is, filmmakers weaving live visions of galaxies, musicians uniting the entire world in a single instant of sound. Could art become more universal, transcending the boundaries of culture and geography, binding humanity more closely through immediacy? Or would it remain what it has always been, local, personal, unique to each culture and heart, even in a universe of faster messengers? So I ask you, if light carried every image, every song, every story more swiftly, would our art be transformed beyond recognition? Or would it simply find new ways to tell the same timeless truths? Perhaps the answer is both. Art would evolve, yes, shaped by new tools, new speeds, new visions. But at its core, it would still be what it has always been, the act of turning mystery into meaning, of turning the silence of the universe into something human. And maybe that is the quietest truth of all. No matter how fast light runs, imagination runs faster. No matter how swiftly photons race, the human heart still beats at its own rhythm, creating art not because of speed but because of longing. And in that longing we find beauty, no matter the pace of the cosmos. What would religion and philosophy look like if the speed of light were 10 times faster? Would the way we think about gods, about eternity, about meaning itself, take on new shapes under a swifter cosmos? Faith has always been bound to the heavens, to the movements of stars and the mysteries of the sky. Philosophers, too, have long gazed upward, asking what it means to exist in a universe so vast and so slow to reveal itself. If light arrived quicker, would our reflections grow sharper, or would mystery only deepen in new directions? Imagine ancient people looking up at the stars. In our world, they were seeing messages millions of years old, unknowingly staring into the past. But in a faster light universe, those stars would reveal themselves more nearly as they are, closer to the present moment. Would myths have been different if humanity had felt the cosmos alive with immediacy, not ancient and unreachable? Would gods have been seen less as distant, timeless figures and more as neighbors dwelling just above the horizon? Philosophy, too, might have turned differently. Thinkers often spoke of the heavens as eternal, unchanging, precisely because they saw the slow drift of stars across centuries. If light were faster, perhaps the changes of the sky would appear clearer, galaxies shifting, stars flickering out of existence closer to real time. Would philosophers have concluded that the heavens were not fixed and eternal but fragile and fleeting, like life on Earth? Would ideas of permanence and divinity have been reshaped into visions of impermanence and flow? Consider also the notion of prophecy. Many religions have framed divine signs in the movement of the heavens. Comets, eclipses, new stars appearing in the night. If those events were visible sooner, closer to their real occurrence, would faith have tied itself more closely to immediacy? Would prophets have spoken less of eternity and more of presence, less of the far-off future and more of the unfolding now? The sacred might have been understood not as distant but as instantaneous, a voice speaking without delay. And what of the concept of eternity itself? Religions often describe the divine as timeless, existing beyond human perception. Yet much of our sense of timelessness comes from the distance of starlight, from knowing the heavens are old. If light were faster, that distance would shrink. Would eternity still feel the same if the stars seemed closer, younger, less like relics of infinite time and more like companions in the present? Would believers find comfort in that intimacy, or would they mourn the loss of the ancient mystery? Philosophy, in its quiet way, would also wrestle with time. Think of thinkers who wondered about cause and effect, about free will, about whether the universe unfolds with purpose or by chance. If information could travel faster, would debates about determinism take on new tones? Perhaps the faster universe would make cause and effect feel more immediate, less stretched across gulfs of distance. Would philosophers argue that destiny itself was sharper, quicker, less forgiving of delay? Or would they see in the swiftness a new kind of freedom, a looseness in the threads of time? Religious rituals, too, might evolve differently. Many are shaped by the cycle of day and night, the timing of seasons, the phases of the moon. These cycles would still exist, for they are tied to Earth's motion, not the speed of light. Yet the meaning drawn from the heavens might change. Imagine a ritual performed under a star not as a memory of ancient light but as a greeting to a star in its present state. Would the prayers feel more connected, less symbolic, more literal in their immediacy? And what of sacred texts? Stories of creation often describe light as the first gift, the first act of divine will. Let there be light, they say, as though illumination itself were the essence of existence. If light were 10 times faster, might those words carry new weight, suggesting a divine force not only radiant but urgent, reaching everywhere with near-instant touch? Would spiritual traditions speak of a cosmos where divine presence is immediate, racing to embrace all of creation without delay? Consider also the way humans grapple with mortality. Faith often offers comfort by placing human life within a greater eternity. The stars, so ancient, remind us of our smallness and of something larger. But if starlight were younger, closer to now, would we lose that comfort? Or would we gain another kind, the comfort of knowing that the universe itself shares our present moment, that we are not separated by gulfs of time but live alongside the cosmos in real communion? Mysticism would also find new symbols. Mystics often speak of unity, of collapsing the distance between self and the divine, of entering timeless awareness. In a faster light world, that collapse of distance would be mirrored in the physical cosmos itself. Would mysticism flourish more widely, supported by a universe that already seems to erase delay? Would visions of oneness feel less metaphorical and more real, woven into the very physics of light? But philosophy might also grow restless. Faster light could reveal more of the universe, push horizons outward. Would thinkers conclude that mystery was shrinking, that the unknown was being devoured by immediacy? Or would they realize the opposite, that mystery only expands no matter how fast we receive its messages? For every question answered, new ones bloom. The faster the light, the faster the questions arrive. Would philosophy then shift from pondering distance to pondering abundance, from asking what lies beyond to asking how to dwell within a universe overflowing with immediacy? And what about the notion of communication with the divine? Prayer is often imagined as words rising into heaven, slowly reaching ears beyond human comprehension. In a swifter light universe, would prayer feel instant, answered as quickly as it is uttered? Would believers feel more assured, more intimate with their gods? Or would they begin to doubt the very delay that gives prayer its patience, its humility? A God who answers too quickly might seem less mysterious, more human. Would faith then grow stronger or weaker under such immediacy? Think, too, of ethics. Many philosophies wrestle with responsibility, with the consequences of action rippling outward. If the ripples of light spread faster, would responsibility feel heavier, more immediate? You would know that your choices, your actions, influence the world without pause, that their echoes travel instantly. Would this make humanity more careful, more aware of its impact? Or would it numb us, the way instant communication today sometimes dulls our sense of consequence? There is also the question of awe. Religion and philosophy are both sustained by awe, by the feeling that existence is larger than us. Awe often comes from delay, from knowing that starlight is ancient, from feeling time stretch across gulfs. If light were faster, awe might need to find new sources. Perhaps it would shift from the distance of stars to the speed of connection itself. Would we marvel less at the age of the cosmos and more at its immediacy, its refusal to hesitate, its urgent presence? And you, listening to these questions, what would you feel beneath such a sky? Would you find comfort in immediacy, a sense that the divine is close and attentive? Or would you miss the slow, ancient grandeur, the way starlight teaches us patience, humility, and perspective? Perhaps both feelings would coexist, the intimacy of presence and the longing for eternity, braided together into new traditions, new philosophies, new forms of wonder. The thought lingers like a hymn carried on the wind, a universe with swifter light, a cosmos more immediate. Would our souls feel more at home in such a world, or would they still ache for distance, for mystery, for silence? Perhaps the answer is not one or the other, but the very tension between them. Faith and philosophy might not dissolve under faster light. They might only deepen, finding new ways to turn the same eternal questions toward the stars. What would history itself look like if the speed of light were 10 times faster? Would the way civilizations rose and fell, the way empires expanded, the way knowledge spread across the earth, have been altered by swifter messengers? History is not only made of battles and rulers, but of communication, of how quickly word travels, how fast news reaches the edge of an empire, how soon an idea sparks in another mind across the sea. If light had always been faster, would our past be written with different ink? Think first of the earliest fires. People gathered around flames, their only source of light beyond the sun and stars. Firelight itself would not change in this alternate cosmos. It is bound to the energy released in burning, not the cosmic constant. But imagine the stars above, closer in time, shining not as ancient voices but as living presences. Would early humans, gazing upward, form different myths? Would the heavens feel less eternal, more alive, more woven into the present moment? Perhaps their stories would describe gods who were not distant guardians of timeless skies but companions walking alongside them in the now. As civilization grew, so did the need to send messages. Couriers on horseback, signals of smoke, drums echoing through forests. All were slow, earthbound methods. Yet as soon as mirrors and torches were used to flash signals across distances, light became part of history. If light were faster, would such signals stretch further, clearer, more reliable? Could vast empires have coordinated with greater ease, their armies moving in tighter synchrony, their capitals ruling with less delay? Might wars have unfolded differently, victories claimed sooner, defeats averted by swifter news? Then consider the spread of ideas. The printing press carried words far, but ships carried them slowly. Yet light carried those words to the eye of each reader. In a faster light world, would lenses and optics have developed differently? Could telescopes and microscopes have revealed truths earlier with sharper clarity? If so, would the scientific revolution have dawned sooner? Galileo's telescope showing not faint echoes of Jupiter's moons but vivid, near-immediate visions of a living sky? Would Newton, seeing a universe so responsive, write different laws or perhaps discover more? History is shaped not only by tools but by perception. Wars were fought because of miscommunication, alliances forged or broken because of delay. In our world, a message sent by ship might take weeks, changing the outcome of treaties and battles. If light had been faster, would humanity discover long-range communication earlier, flashing codes across oceans, sending signals further with simple tools? Could the telegraph, which transformed the 19th century, have been imagined centuries earlier, sparking a different path of history? Might the world have grown smaller, unified faster, with knowledge and power concentrated in new ways? Think also of exploration. When sailors set out into unknown seas, they navigated by stars, trusting the heavens to guide them. With faster light, the stars would still shine, but their presence would feel fresher, less like memories and more like companions. Would explorers interpret them differently, believing the cosmos was more immediate, less bound to ancient ages? Would the urge to explore have carried a different flavor? Not just curiosity for distance, but a sense that the universe was unfolding with them, step by step? And then, photography, when humans first learned to trap light on paper to fix moments in time. If light had always moved tenfold swifter, would cameras have been invented earlier, refined more quickly, giving us a record of history far richer, far deeper? Could we hold in our hands images of civilizations long gone, captured not as grainy glimpses but as living clarity? What would it mean for our sense of history if we had sharper windows into the past, not filtered by delay but framed by immediacy? Think of great events, the fall of Rome, the voyages of discovery, revolutions shaking continents. Much of what shaped them was delay. News arriving too late, reinforcements missing their moment, whispers spreading slowly through streets. In a faster light universe, would information spread more quickly even before electricity, through reflections, through devices invented earlier? Would revolutions ignite faster, empires crumble sooner, because ideas carried swifter weight? Or would rulers, too, wield that speed, tightening their control, preventing dissent before it had time to grow? Then comes the modern age when electricity turned light into messenger. Telegraph wires crisscrossed nations, later fiber optics circling the globe. But in a faster light world, each stage would leap further. Could the 20th century have unfolded with technology centuries ahead? Would space travel come not in 1969 but long before, guided by instruments more precise, more immediate? Could humanity, in such a history, have set foot on other worlds already, writing chapters of exploration while our own history was still young? There's another side, though. Would swifter light necessarily mean swifter understanding? Knowledge does not always travel at the speed of its messengers. People resist, doubt, cling to old ways. Even if information arrived instantly, would minds and societies be ready to receive it? Perhaps history would still follow a similar rhythm, because change is not only about physics but about hearts and choices. The cosmos might quicken, but humanity might still take its time. Consider culture as well. Art, philosophy, religion, each rooted in the perception of light and time. A faster light universe might have given us myths less tied to eternity, philosophies less grounded in permanence. Would art reflect immediacy, capturing moments as they are rather than longing for what is distant? Would religions frame the divine as a presence always here, not far away? Would history itself be told differently, less as a story of ages stretching long and more as a tapestry woven of moments shared in real time? And yet, perhaps nothing changes. perhaps history remains what it is. The story of human striving, human folly, human wonder. Faster light might change the tools, but the impulses remain. Curiosity, fear, ambition, love. History is not only about what is possible but about what people choose. And no matter how swift the messengers, those choices take time, shaped by culture, by memory, by the slowness of human growth. So then, the question lingers. If light had been 10 times faster, would we stand today in a world unrecognizable, with civilizations leaping centuries ahead? Or would we stand in much the same place, because human history unfolds not only in physics but in the pace of our hearts, our communities, our learning? Perhaps both are true. Some paths would change, wars altered, discoveries hastened, empires reshaped. Yet beneath those changes, the rhythm of humanity might remain, always seeking meaning, always telling stories, always building and breaking and building again. The speed of light might alter the stage, but the play would still be ours to write. And you, listening now, what do you feel? Would you prefer a history swifter, sharper, more immediate? Or do you cherish the slow unfolding, the way civilizations bloom like seasons, each in their time? The answer rests not in the past but in our imagination, because to wonder about what might have been is to realize that history is still alive, still being written with every choice we make. What would the future look like if the speed of light were 10 times faster? Would our descendants step into a reality more connected, more immediate, less patient than ours? Or would they find that even with swifter messengers, mystery remains? The future is a canvas we cannot see, yet we imagine it constantly, filling it with spaceships, cities among the stars, networks spanning galaxies. But if the very constant of light were different, would the strokes on that canvas be painted in brighter, quicker lines? Think first of space travel. Today, the dream of venturing beyond our solar system is bound by distance. Even the nearest star is so far that light itself takes years to arrive. If photons raced tenfold faster, the nearest star's light would reach us in months instead of years. Would that shrink the gulf of space in our imagination, making other stars feel less unreachable? Could explorers plan journeys with less despair at the vast silence between worlds? And if so, would humanity step outward sooner, braver, guided by a cosmos that seemed to answer more quickly? Communication with distant colonies is another question. Imagine a settlement on Mars or a station orbiting Jupiter. In our universe, messages take minutes or hours to travel between Earth and these outposts. But in a faster light reality, those messages would be nearly instant, as if no distance lay between. Would this erase the loneliness of space, making colonies feel like neighborhoods instead of exiles? Or would it make humanity overconfident, forgetting the true distances, mistaking faster signals for a smaller cosmos? Technology of the future would evolve differently as well. Computers already rely on the pace of light, their circuits racing with signals nearly instant to us. With faster light, the ceiling of computation would lift higher. Could we imagine artificial minds processing not just faster but in ways so immediate that they seem to think alongside us, without pause? Might future generations converse with intelligences so seamless they blur the line between human and machine, not as tools but as companions in thought? And if so, would that comfort us? Or would it trouble us? This intimacy with something born not of flesh but of photons. Energy, too, would shift. We speak now of solar power, of harnessing the sun's light to sustain civilization. In a faster light universe, might that energy be transmitted across vast distances without delay, cities on Earth powered by satellites in orbit, or even by stations near the sun itself? Could humanity grow into a species not bound by fossil fuels or scarcity, but by a cosmos that delivers energy with unprecedented efficiency? And yet, would abundance solve our struggles, or would it simply shift them, creating new questions of responsibility and balance? Consider also medicine in the centuries to come. Lasers already heal, illuminate, and diagnose. A faster light reality might give doctors sharper instruments, clearer visions of the body, quicker signals between machines. Could diseases be cured before they take hold? Scans revealing their secrets instantly, treatments delivered with perfect precision? Would lifespans stretch longer, health endure more steadily, as though light itself conspired to preserve us? Or would humanity still discover that mortality, though delayed, remains part of life's pattern? And then there is art of the future, bound always to imagination. With faster light, digital realities could become indistinguishable from life, artists building worlds you could step into, stories you could live as though real. Could future generations dwell in shared dreams, entire cultures blossoming in virtual landscapes shaped by photons dancing at unimaginable speed? Would art dissolve the line between reality and imagination, creating futures where the two are no longer separate but woven seamlessly together? Philosophy would continue its endless questioning. Faster light might reveal more of the universe, new galaxies, new horizons. But for every answer, questions multiply. Would future thinkers find that immediacy brings clarity, or would they realize that mystery only deepens, that the faster we learn, the more we see how much we do not know? Perhaps the future would teach us humility, that no matter how swift the messengers, the unknown is infinite. Religion, too, might evolve. Faster light could make the divine feel nearer, presence more immediate. Prayers might be imagined as answered without delay, rituals framed around the intimacy of a universe always close. Yet would faith lose some of its depth without the patience of waiting, without the poetry of distance? Or would it grow into new forms, celebrating immediacy as a kind of miracle, a closeness between humanity and cosmos that feels sacred in itself? But perhaps the most intriguing question is not about stars or gods, but about ourselves. Would humanity change if the universe seemed more responsive, less delayed? Would we grow impatient, expecting life to move as quickly as photons, demanding instant answers to every longing? Or would we learn balance, realizing that even in a swifter cosmos, some things remain slow, hearts learning to love, children growing, seasons turning, wisdom ripening with age? The future, faster light or not, may still require us to honor slowness. Think of generations to come, looking at the sky. They might see galaxies not as ancient relics but as living neighbors, their light fresher, their presence closer. Would those descendants feel less lonely, more connected to the cosmos? Would they dream not of faraway worlds but of present companions, stars alive with immediacy? And in that dreaming, would they feel stronger, braver, more eager to wander outward? There is another possibility, gentler and quieter. Perhaps faster light would change little of essence. The sun would still rise, the moon would still wax and wane, rivers would still carve valleys, and people would still fall in love beneath the same sky. The pace of photons might shift the edges of knowledge, the fabric of technology, the timing of history, but the rhythm of human life might remain, the rhythm of laughter, of sorrow, of wonder. The future, then, might be less about speed and more about meaning, less about immediacy and more about what we choose to do with it. So what would the future look like? Perhaps it would be dazzling, filled with colonies among stars, machines of infinite thought, art blooming in realities unbound. Perhaps it would be quieter, filled with families still gathered under skies, still telling stories, still asking questions. The truth is that faster light might give us new tools, but the essence of the future remains in our hands, in our choices, in our capacity to dream. And you, imagining this, what do you see? Do you picture cities shimmering across worlds, connected by instant signals? Do you imagine children playing in digital landscapes as real as their homes? Do you dream of philosophers and poets still asking questions, still marveling, still finding beauty in the mystery? Perhaps the future, in all its swiftness, will still be what it always is, a horizon of wonder, an invitation to step forward with courage and curiosity. The thought lingers, soft as starlight. Even if light were 10 times faster, the most important truths might remain unchanged. The universe would still be vast, still mysterious, still capable of humbling us with its silence. And humanity would still be here, asking, imagining, reaching. The future, faster or slower, is not a matter of physics alone. It is a matter of wonder, and wonder, unlike light, is infinite.